Here we have a problem on compound interest. Okay, let's go with the information. Jake has a bank account that earns 5% interest compounded annually. After 8 years, he has a total of $4,000 in the account. Which of the following represents the value of his initial deposit? Okay, the final value of the deposit is given that is $4,000 after 8 years, and the rate of interest is 5%. It is compounded annually. We have to find the initial deposit. Okay, first let me write the formula for compound interest. That is A equals to P times 1 positive R over N to the power of N times T. Here, let's understand the components of the formula. This A represents the final value of the deposit, and this P represents the principal or initial value of the deposit. This R is the rate of interest that can be written in decimal. So this N represents the number of times interest is compounded annually, I mean the per year. And this T represents the time period of the investment in years. Okay, here we know the value of A, that is the final value of the deposit, that is $4,000. We can plug in 4,000 for this A. And this P represents the initial value of the deposit, that is what we have to find. And 1 positive. So this R is the rate of interest in decimal. So the rate of interest is given, that is 5%. So let's convert this 5% to decimal. Whenever we have percentage, it has to be divided by 100. So when you divide 5 by 100, it's 0.05. So 5% equals to 0.05. That is a decimal form of 5%, 0.05. We can plug in this value for R over here, 0.05. And this N represents the number of times the interest is compounded per year, that is in 1 year. Since here in our problem, interest is compounded annually, so that is interest is compounded once in a year. Since interest is compounded once in a year, the value of the N over here is just 1. To the power of, here also we can plug in 1 for N, the number of times interest is compounded in a year, times T represents the time period of the investment in years. So here the time period of our investment is 8. So we can plug in 8 for T. So then we get 4,000 equals to P times 1 positive. So when I divide this 0.05 by 1, still it is 0.05 to the power of 1 times 8 is just 8. Now we get 4,000 equals to P times, when I add 1 and 0.05, I'm getting 1.05 to the power of 8. Okay, so our aim is to solve for the initial deposit that is given by P. So we have to isolate P. For that we have to get the value which is over here, I mean which is multiplied by P. For that I divide both sides by 1.05 to the 8th power. Let me do it on the left side also, 1.05 to the 8th power. So this one and this one are cancelled. I'm getting 4,000 divided by 1.05 to the 8th power equals to P. So now I got the initial value of the deposit, that is 4,000 divided by 1.05 to the 8th power. So we find this value in option B. So the correct answer choice for this question is option B.